Hello everyone. So today we are going to discuss class level a very basic topic, that is limits, and based on this topic later on we are going to learn differentiation, then later on in class 12 we learn integration. So all of these concepts are based on this topic limits. So that's why we have to understand this topic very clearly so that we face no difficulty when we further study regarding differentiation and later on regarding integration. So without wasting any time, let's start with the topic. So I'm Michael Dutta, you all are watching GANITMATICS, ab har sawal hoga sawal. So let's see. Now, to understand limits, we have to first understand a very small term that is called neighborhood. So let's understand that what neighborhood is all about. Okay. Now in low classes, you all have learned regarding number lines. So let me take a small example of a number. And suppose this is 0.1. This is 2 and this is 0. Okay, 0, 1, 2, 3 points are taken, marked in that way. Okay. Now, if I consider a particular point, say this one, 1. Okay. Now, if I take a small real number after 1, say till here, and of the same value on the left side also, so you all can see that I'm getting a region from here to here around 1. Right. But yes, we have to keep that in mind that this small real number is a small number, something like 0.1, 0.2, 0.3, something like that. Okay. Now the point is, this region that we are getting around the 0.1, this is called a neighborhood. In general, neighborhood means what? Something which is around us, right? In the same way here also, this entire region which is around this 0.1 on both the sides as a total is known as the neighborhood of this 0.1. Okay. Now from this region, if I just delete the 0.1, then the same neighborhood will be termed as the deleted neighborhood. Okay. Understood? Now, based on this neighborhood concept now, we are going to discuss limits. Now you all know what functions are all about. Those who don't know, you can get a link on the top of this video and you can go and just watch that video regarding functions to know what the function is all about. Because we are going to bring function here in the limits to understand the concept, and all of these concepts that we are going to learn one by one will be based on the concept of relations and functions. Basically, the functions. Okay. Now, so let us take a function, say fx is equal to 2x. Now, we are going to see here that if I take a particular point and if I approach a particular point, so basically the point that I am talking about is the x. So obviously, as we know that x is the input here for this function and the value of the fx is going to be my output, right? Now, so for this x, now we are going to see here that if I approach a particular value of x, then the value of fx will also move towards a particular value of fixed value. Okay, so let us see with the table. So to understand this concept, I have taken few particular values of x, as you all can see here. Now I have taken the values of x in such a way that that particular value of the inputs is approaching 1. Okay, so x is approaching towards 1, and in other words, we can also say that x tends towards 1. So x tends to 1. Okay, we can also say in that way. Now see, here the values of x that I have taken, they are all approaching towards 1. See, 0.9, then 0.95, then 0.99. So they are moving towards the value 1, right? These are all the inputs. Now with respect to these inputs, now see the output of the function. For the first one, for 0.9, we got 1.8. For 0.95, approaching towards 1, now see the output is coming 1.9. Then for 0.99, the output is coming 1.98. So, if my input tends towards 1, then my output is tending towards 2, isn't it? Right? So, that means for any input which is approaching towards a particular value, and for that, if the function value tends toward a fixed number, like in this case, it's tending towards 2. Then this 2 will be the limit of this function. Okay, so that means limit is basically a number towards which the value of a function tends if the input tends towards a particular number. So that is what the limit is all about. But to understand it in a better way, we'll also see few more cases and we further discuss regarding limits in this video. Okay, so let's continue. Okay, so now let's generalize the fact that we have discussed right now. So we have seen a function which was fx equal to 2x. Now we have seen that from that function we were getting a particular value, isn't it? That the function was tending towards a particular value, and this one is called the limit. Okay. Now the value towards which the input tends to, that is what we are writing here. So this, in general, we write it this way, that limit x tends to a, fx is the function and that is equal to L, which is the limit of that function. In the previous case, where 2 was the limit and 2x was the function and x was tending to 1, right? Now see, so this is a basic formula. You all can treat this as a formula. So that means if you want to find the limit for any function, then what you have to do is, whatever value the input is tending to, like you can see here in general we are writing that limit x tends to c fx is equal to fc. That basically means in that function you just simply substitute x as c. So in that function, if you directly substitute x as c, then whatever value you all will get, that will be your limit. Okay, so that is how we find the limit. But obviously the thing will be not that easy in every case. So there are difficult situations also that we are going to get later. Okay, now let's move on to the next concept, that is on the left hand limit and the right hand limit. Now let us understand this in an easier way. Now just now I have showed you all that table, right, where we have taken values. So if I again consider the same, so let us take the table once again. So where the x values, I have taken some values like 0.9, then 0.95, then 0.99. So if you see here that the inputs that were approaching towards 1, that was from the left side of 1. These values are all approaching towards 1 from the left side. Now what if the value tends to 1 from the right side? That is also possible, isn't it? So at 1.1, what is going to be my output? It's going to be 2.2, right? Then at 1.05, it's going to be 2.1. Then at 1.01, it will become 2.02. So you all can see here that as I'm approaching towards the value 1 from the right side, then the value of the function is also approaching towards 2. That is from the right side. And from the left side, when we are approaching the value of x from the left, then the value of the function is also approaching towards 2 from the left. So it doesn't matter that we approach towards a particular value from the left hand or from the right hand, when the limit is coming to the same place. But yes, I'm not saying that every time it will be the same, but in such cases we are getting that. Okay, so when the limit we are getting from the left end, then that is called the left hand limit. And similarly, when we are getting the limit from the right end, then that is called the right hand limit. So that is what the difference between the left hand limit and the right hand. Okay, clear? Let's proceed further. Okay, now finding the limits of every function is not going to be that easy every time, because there are a few problematic cases that I'm going to show you all now. So now sometimes you will see that for few particular functions the limit might come, or when you substitute, like if you are directly substituting the value of say in the function, then the values might come in this way. Like say it might come in the form 0 by 0, or it might come in the form infinity divided by infinity, okay, or some other forms of the same type. So whenever we all are getting the terms of this way, like 0 by 0, infinity by infinity, infinity minus infinity, if we are getting values in this way, then we can't say what is the exact value of the limit. And such cases are known as indeterminate forms. Such cases are called indeterminate forms. And there are particular techniques to deal with indeterminate forms, and we'll see how we are going to deal with such cases. Okay, so I'm going to show you all one example which I'm talking about, then I think it will be more clear. Now let me take a function, say my fx is, say for example, I'll take my fx as x square minus 1 divided by x minus 1 and limit tends to 1. If you all clearly see here that if I directly try to substitute the limit here, like if I directly substitute the value of c, then 1 if I substitute in place of x, then will become 1 minus 1 0, and here also 1 minus 1 will become 0. So I'm getting the 0 by 0 form, which is, as I told you all, we can't determine the values in such cases, and these are known as the indeterminate forms. So how we are going to deal with this? Let's see. Now there are two such cases. Okay, either the function is in algebraic form or it is not in algebraic form. These are the two cases we all will get. Now if it is in algebraic form, then there is a technique using which we can solve. Like since this case is the algebraic case, so here I'll show you all how we are going to find the limit, right? What is the technique to solve such cases? See, so what we will do here, we will factorize the numerator here. Okay, it's in a rational form, it's a rational function, right? So we will first work on the numerator. Now you all can see that the numerator we can factorize it, right? In the form of a square minus b square. So if I split it, it will become x minus 1 into x plus 1 divided by x minus 1, limit x tends to 1. So you all can clearly see that x minus 1 and x minus 1, these two factors are cancelling out, isn't it? So we are only left with x plus 1, and now I can substitute the value of c, and there is no problem, because if I substitute here, then 1 plus 1 will be 2. So that means the limit of this function is coming out to be 2, but for that we have applied the technique, but that technique we are only applying when we are discussing the algebraic case. So this is a technique you all will keep in mind whenever you are dealing with the indeterminate forms and you have an algebraic situation. But yes, it's not mandatory that every time you all are getting an algebraic situation. If you are not getting an algebraic situation, then how to deal with those, that I am going to discuss right now. Okay, so let's proceed to those cases. Now we'll see how to deal with the non-algebraic cases, right? So non-algebraic means it can be exponential, it can be trigonometric, right? So for such cases, we will follow certain formulas. So let us first see for the trigonometric cases. Now for trigonometric cases, these are the few formulas that may apply according to the situation. And after that, I'll also show you all few particular sums related to these types so that the concept is more clear regarding this. So the first one that we need to know is limit x tends to 0, sine x by x is equal to 1. Okay, this is a formula that we can apply and it's a very useful one. The second one is when it's related to tan. So limit x tends to 0, tan x by x is equal to also 1. And another one is related to cos, but the form is a bit different. Limit x tends to 0, 1 minus cos x whole divided by x is equal to 0. So these formula we all can apply when we are dealing with the trigonometric cases. Although there are few other formulas of limit as well, which according to the situation you all may apply, right? So let us see those other cases as well. Like if we have exponential, then limit x tends to 0, e to the power x will be 1. This we can also tell from the exponent concept as well. Now, next is limit x tends to 0, log 1 plus x, if it's a logarithmic function, whole divided by x, that'll be 1. Then limit x tends to 0, a to the power x minus 1 whole divided by x, that will be log a, but it's provided that a should be greater than 0 and a will not equal to 1, because as we all know, for log 1 the scenario will be not defined. Then we have another one when limit x tends to 0, e to the power x minus 1 whole divided by x is equal to 1. And the last one is limit x tends to 0, 1 plus x whole to the power 1 by x is equal to e. So these are few non-algebraic cases. If we get, then we can take help of these formulas and we can solve our sums and we can get the limit of the given function if it is non-algebraic. Okay, so now I'm going to show you all few such cases. I'll also solve few problems so that you all get a clear idea regarding such cases. Okay, so let's see. So I'm going to select few sums from the NCERT and from the ISC books. I'm not mentioning a particular exercise or a particular sum. So I'll just give few examples collected from all these books so that you all get a clear picture regarding the same. So let us first see a simple example. The first one, when we have to find limit x tends to 0, x plus 1 whole to the power 5 minus 1 whole divided by x. Now, if I see this particular sum, and now here if I directly substitute the value 0 in place of x, then you all can see we'll get 1 minus 1, 0 in the numerator, and denominator will be also 0. So it's a 0 by 0 case. So obviously we can't do by that concept, right? But although one formula is there which I haven't mentioned that time. Now you all make a note of that. So if we have any function in this form, so this is applicable for any positive integer n. Okay, that limit x tends to a, x to the power n minus a to the power n whole divided by x minus a is equal to n into a to the power n minus 1. Okay, this is a formula that we can apply anywhere, but we have to keep that in mind that n needs to be a positive integer. Only in such cases we can do so. Okay, it needs to be a positive integer. Now, if I apply this concept for this sum, then we can see here that we do have a power here for x plus 1, but that is for x plus 1, not x. Okay, so in that case what we'll do is we'll first try to bring it in that form, and for doing so we have to assume x plus 1 as some variable, isn't it? So let us do it in this way. Let us consider. So in limit sums, we can assume, but one thing we all have to keep in mind that the limit that was given in the sum was with respect to that form. Now, if we are doing any substitution, then our limit will also change. How it is going to change, I'll show you all. See, so if I substitute x plus 1 equal to y, okay, then our limit was what? X was tending to 0. Now, you see here in this substitution, if x tends to 0, then what will be the value of y then? X tends to 0 means if I consider 0 in case of x, so then y will become 0 plus 1. So y is becoming 1 then. So we will write them this way, that if x tends to 0, then y tends to 1. And in the sum also we have to change the limit accordingly. So we'll now change the variable. So we'll do it in this way, that limit y tends to 1. Always remember always remember this, that if you are changing the variable, if you are doing any substitution, then in the limit also it will change. Okay, so it will become y to the power 5 minus 1, and x in this case will become, so if I find the value of x from here, it will become y minus 1. So I'll substitute y minus 1 here. Now if I say this formula that just I gave you all, so now this particular sum is absolutely in the same form that the formula is given in, so we can apply directly. So it will become n. Here n is how much? Here n is 5, right? So it will be 5 into, what is a here? A is 1, because 1 means it's 1 to the power 5. It's the same thing. Value will remain 1 only. So it will be 1 to the power n minus 1, which means that's 5 minus 1. So 1 power anything becomes 1 only. So the final answer will be 5. So this type of sums also we can deal. Yes, if you need any substitution, then definitely you all can do so. Okay, so this is one example that I would like all of you to know. I hope it's clear now. So let's move on to the next one. Question number 2, or example 2, whatever you call it. Now, suppose we have something like this, that we have to solve this, where we have to find limit x tends to 3, x to the power 4 minus 81 divided by 2x square minus 5x minus 3. Okay. Now, if I directly want to solve, if I directly want to substitute, then you all will get indeterminate form. So here also now, but this is an algebraic case, and we know the technique how to work in algebraic case, we try to factorize. So here also we'll do the same, right? So x to the power 4, we all will write it as x squared whole square, and 81 is 9 square, we all know that. And this one, the denominator that we have, we can apply middle term factorization, and I'm just telling you all later on you all can check this. If we factorize, it will become x minus 3 into 2x plus 1. You all can check doing middle term factorization that you all have learned in lower classes. So now in this case, so the denominator that we have right now, so that we are going to write now as x minus 3 into 2x plus 1. Okay. Yes, so after that we can also will factorize the numerator. It will become x squared plus 9 into x squared minus 9. So this will be x minus 3 into 2x plus 1. So we can further split. So in that case, it will become x squared plus 9, and that we can further break as a square minus b square as x plus 3 into x minus 3, and whole divided by x minus 3 into 2x plus 1. So x minus 3 and x minus 3 will cancel out. Now you all can take x as 3. You all can substitute there. So we'll be getting in that case 3 square. So 9 plus 9, 18. Then 3 plus 3 will be 6. And here 3 into 2 will be 6 plus 1, 7. So the final answer is coming as 108 by 7. Okay. So algebraic form, I think now will be pretty clear to all of you that how we are going to deal with such cases. I guess it's clear. Now it's time to move on to the next example. Okay, now let us see a sum where we have a non-algebraic situation and an indeterminate form as well. Okay, so let's see, limit x tends to 0, sine ax divided by bx. Now you all can see here that if I directly substitute the value of x as 0, then sine 0 will be 0 and denominator will be also 0. So it's becoming 0 by 0 form, which is an indeterminate form. But just now, few minutes back, we have seen formulas with respect to sine. So, but that form was sine x by x. So I have to bring this in the form sine x by x. But instead of sine x, we have ax. So that means we need something as ax in the denominator, then only we can apply. Okay. But to do so, the thing that we need to do here, ax, if I introduce, then to cancel it out, I have to take another ax in the numerator as well, and bx will be as it is. But still, it is not in that form. So we have to assume ax as some variable. So let us consider that as, say, y. And if limit x tends to 0, so you can see here, if I substitute x as 0, then y will be also 0, right? Now we'll change the limit. Now, limit formula is very much applicable on addition, subtraction, and division. Okay, so what I mean is this. So because we're going to apply this concept here, and that is the reason why I'm discussing this with all of you. This is called the algebra of limits. So what I mean is, so if we have something like limit x tends to a, and there is a sum of two functions like this, then you can split it in this way, that it will be the limit of the first one plus the limit of the second. Okay, the same thing is applicable on subtraction as well. Same is applicable for multiplication as well. You can separately write the limits and then their product you can do. Like what I'm trying to tell is this, like limit x tends to a fx dx is same as telling limit x tends to a fx into limit x tends to a gx. The same thing is also applicable in case of division as well. So we are going to apply that concept here. So if I separate, then limit x tends to 0 sine ax by ax. Okay, and here x and x is already cancelling out into limit x tends to 0 a by b. Now since it's a constant, so it will make no change. It's a constant, x is not going to change it. So a by b will come directly outside as a constant. And since I've assumed it as y, I have assumed ax as y, so this will become limit y tends to 0 sine y by y. Always remember when you are doing this type of sums in exam, that unless and until you bring that limit in the particular form of the formula, you can't apply the limit. Okay, that you all need to show. So now this will become 1. So the final answer will become a by b. So in any such non-trigonometric cases, you all can apply the same technique and you all can solve it. Okay. Now one last sum which is a bit different, and then we'll wrap this particular topic. Last sum, question number 4, an example. Let's see. So we have limit x tends to 0, a bit different this time, cos 2x minus 1 divided by cos x minus 1. Now cos 2x, we all know the formula of cos 2x. So what we'll do here is, let us convert cos 2x in form of cos, right? So in that case, what will become? It will become twice of cos square x minus 1 and another minus 1. And this cos x minus 1, let it be as it is. Okay. So now if I see, then this becomes twice cos square x minus 2. Okay, no problem, I guess. Now just we'll take that 2 common outside. It's a constant, so it's becoming cos square x minus 1 divided by cos x minus 1. Okay. Now, although this is not an algebraic sum, but the technique that we have applied in algebra here for this particular sum, it is working, because cos x, if I think as a single variable, then the technique will work here. See why I'm telling so, because if I break cos square x minus 1 as a square minus b square, it will become cos x plus 1 into cos x minus 1, right? And we have a cos x minus 1 in the denominator, so these two will cancel out. And now this form as we got, now we can directly substitute the 0, so it will become twice of cos 0 is 1 plus 1, so it will be 2 into 2, so the final answer is 4. Okay, so according to the situation, we have to act. I hope now understanding all of these concepts will give you a lot of confidence for this particular topic, and we have seen a lot of examples related to all the cases of limits and how we are going to deal with it, how to find it, how to solve it, what limit is, everything we have discussed. So we have covered the entire topic, and I hope that this video is going to help you a lot regarding this particular topic. So all the best. So later on in the next video, we'll start with the derivatives, which is based on this topic. So first revise this particular topic, and in our next video, we are going to start with differentiation. So I'm Michael Dutta. You're watching GANITMATICS. Ab har sawal hoga solved. Those who are new to this channel, do subscribe to the channel and click the bell icon. Thank you and have a nice day.